Hi everyone. So for the week 10 part B, where we build a Spring Boot application and Dockerize it. We're going to have a few dependencies in our project. First is Docker to be installed. Then we need to have Maven, and we also need to have Docker CLI, Docker, and Docker Compose. So let's test it out, the things that we need. So if you have Maven, all good. If you have Docker, all good. And you also need Docker Compose. So Docker Compose is to build multi-service containers through one configuration file. The difference between Docker file and Docker compose.yml is Docker file is used to build a single image, and Docker Compose is used to run multiple services in a as a container. So you don't have to pull up MySQL database part one, front end part one. So all you can do it in a Docker Compose file. Just like Docker Compose has three commands: Docker Compose build, Docker Compose up, Docker Compose kill. So we'll see when we go ahead. So right. So these are the dependencies. And we're going to create a project and change things. So for me, I'll close this. I'll create a project in IntelliJ, create a new project. So this looks too big. Okay, so the project says kind of project. So earlier we had created static Spring projects, right? And then we had also created projects built up of Maven archetype. So this one is Spring Initializer project. What Spring Initializer does is that it creates the boilerplate for all the Spring related configurations and things like that. So if you go to this URL, let me pull this up. So if I pull this up and go to spring.io, to the URL that was provided there. If you go there, no. If you go to this spring.io, and you can see this is the all Spring related documentations. You can find it from here. These are the things what Spring can do. So today we'll be creating more or less like microservices. Microservices are the current way in which APIs are built. So if we go to start.spring.io, it will take us to Spring Initializer. So what this helps us to do is it helps us to create that pom.xml. All right. So if I say, okay, get me the Spring Boot, I don't want any latest one. I'll need a stable version one. You want the project metadata to be group Spring Boot dot demo, and artifact you want to keep it as lecture demo. Likewise, so this is how it's going to create. And in dependencies you can add, like I need Spring Web, I need Spring Boot Dev Tools, and I need all this. So Vardin is a web UI framework. Similarly, you have Timeleaf and all to create UIs. FreeMarker is also one of them. So JSF, JSP, Timeleaf, FreeMarker, these are all UI technologies, the web page part technologies. So you have a lot of other things here. So we need Spring Data JPA. So once you have this, you can click on generate. It will create that sample boilerplate project, and you can download it. So you want to explore this, you can click on explore and see the project boilerplate. Boilerplate is something which is generated just like when you do Angular GC, Angular generate components, and then it created all those files and everything. So those are all boilerplate files. You don't have to manually create them. So you can see here, so it uses Java version 11. So I'll just close, I'll go back here and find where is Java. Okay, I want 8 and I want packaging as jar. Now I go back and then I could see the related stuff. So whatever I'm looking at things here, the same thing. This is the web part, and this is ultimate version of idea project. Comes with all this related Spring initializer URL. So it integrates with the initializer service and shows you what things you can do. So if you click on next, so it basically connects to the initializer thing. Uh, so I'll say I need Java 8, the group, I'll say a demo project, um, com.lecture demo, and then I'll keep it as a Maven project, and artifact I'll keep it as a lec demo, and so I'll just keep it as demo. So com.demo.lec demo. So I'll just keep it as lec demo. That's fine. Doesn't matter. It's just a packaging name. So if I do next, I need. I'll select all this later. But yeah, this Sprung. So use a snapshot version because they're a bit stable ones. So I'll choose 1.1.8 and next. So I want to create my project in this directory. That works for me, not an issue. So I'm keeping this in the directory, lab lec demo, and finish. So it will create that project for me there. So it got created here. This project got created here with the boilerplate files. Now, if you see, there are things like import changes. So because of the predefined POM, it will start downloading libraries defined here based on what is defined here. So currently there's just 1.8 Java 8. So there are ways you can click on here, import changes, and it will download, or you can use your terminal and do maven compile. So maven compile. So when you do maven compile, it downloads all the required dependencies that you have mentioned here, because for compile time you need all the related dependency, or you may, so you can also click on import changes, should be good. So it will take a while and download, so that's fine. You can import changes, same thing. So that's good. So once that is done, um, so what you can do is, right. So after you have created your project, you need to add some related dependencies here. Um, for the related dependencies, you can go to GitHub and look for Spring Boot JPA MS SQL Docker and open this POM file. So here I need to add a bit of dependency here. These are the dependencies, data JPA. So I already have this part. So I already have that part. These two dependencies, I just need to add the JPA dependency, the starter web dependency, and MySQL connector, Java connector. So whenever you do this, right, if you see org Spring Boot thing, so org Spring Boot, so it doesn't have uh, the data JPA, starter web, or MySQL connector. So if you import changes or if you do maven compile, uh, it will trigger to read this POM file and download the dependencies. So it will take a while to come up here. So scanning. So these are the mirror repositories from where it is downloading whatever you have mentioned here in the POM file. So in 1 week, we created the project in different way. In second week, we created the project using Maven archetype. Third week, we are using the initializer. So once this is done, you'll be, it takes a while to download. So once this is done, you'll be able to see these projects here. So it includes the data JPA includes related things. So if you see, I've downloaded. Yeah, just click on import changes. So now it got refreshed. Once it refreshes, you can see it gets Tomcat, it gets the Hibernate related Jackson data types and Hibernate things and the Spring Boot data JPA, all these things. So once you have this POM file created, we can start working on the project. So in the project, so whenever you do a Maven compile things, right, it creates a Maven build. So we are not worried about the target at the moment, but we'll see as and when it goes. So in the source package, because you have the base POM file, if you look at um, if you look at this, right, so it has two dependencies, the main one and the test. So because it has test, we have this test here. So what we'll do is next time we build the artifacts or the packaged jar files, we'll skip them. We'll simply use the main ones and we'll skip the test one. I'll show you when we run those commands so that we don't have to run what is there in the test. So here by default, it creates an executable main class. So this is where the application enters the execution in the environment. So in the boot, you don't have to specify to run it in a Tomcat or anything, because it automatically creates and runs a Tomcat instance and then runs the application inside that. Inside Java and uses Apache to talk. So you don't need to do that. So it's all done implicitly. You don't have to do explicitly. So this is what you have. And if you look at your project, you need to add controller entities and repository. So this is this code, controller code under the controller package is pretty much very similar to our previous controller. And then entity and repository is, entity is what maps to the database. Repository is what interacts with the database. You basically use a repository method, a repository interface methods to call your database logic, like find by ID, find all, and things like that. So we'll just create the controller, which controls the navigations, entity, which is like a mapped relation class in your Java. And I think I'll just have some code which I can copy it here. So we'll look into the functional part in some second, but yeah, let me paste this here. So once it adds, so you can see this is the entity class, which is mapped to a table name called Pokemon. And then you have Hibernate initializer and the ID created automatically. And here in the repository, it imports Pokemon. So because I copied from somewhere, another project. So it's under com.demo.lecdemo. correct? So should be good. So when you have a Pokemon repository and it extends JPA repository, you just need to provide the name of the entity class and the primary keys data type. This is very similar to what we have previously. And then you have controller, which manages all the logic. So in the logic part, I'll just have the imports done properly. com.demo dot leg demo, and same here. All right. So once this is done, what it does is like any request coming with a pattern slash API, Spring is going to intercept it as a part of the inversion of control and call the respective methods. So if you see here, we in earlier class we had the service class auto-wired and service having um, an auto-wired repository interface. Um, that is actually a better design, but yeah, for minimalistic thing, we don't need to go very detailed, but yeah, for your understanding, this interface, using this interface, you can call all the entity related methods. So with slash API, if I have slash Pokemons, it's going to call find all method of the repository and return me a list of all Pokemons. Similarly, if I post something and I pass a Pokemon object in the request body, it's going to save that object. And if I have to update an Pokemon, so if you see, this is a placeholder to pass the object ID. I pass the object ID in the path, and in the request body, I actually post like I send put a Pokemon object, and then I get the Pokemon object from the repository and update the name and other attributes based on what is been put. Similarly, delete and get by ID. This is get by ID, where you say get API Pokemons and pass the Pokemon ID. So this is how the APIs will work, correct? So next thing is we need to configure the external resources, that is to connect with the database. So I remember sometime in previous week, somebody, I think someone has asked, are we going to use application properties? So yes, we're going to use it in this week. And what I'm going to do, I'm going to show you a little thing. First, I want to make it work in my local. So this is my local. I have Pokemon DB created in previously, and I'll create a new schema here. So I'll click on this, and the new schema is lecture demo slash DB and apply. So yes, I want to create the schema lecture demo slash DB, and then yeah, so now you have a schema lecture demo with no tables here. That's fine. What I'll do, I will go to the application properties, copy the part. Source, main, resources, application properties. So I want to run it in the local first before I make sure I can, before I can containerize it. So I will place my external resources variables here. So here, JDBC MySQL local host. I want to first test it in my local. And the name of the database, which is lec demo underscore db, which I just created. And the username would be root, and the password in my local MySQL is root pass. So usually this is actually a MySQL user and MySQL password. And because I'm running in the local, I have one more thing. I need to pass the time zone in the database URL. So I'll check my previous repository, the MVC data JPA. And so in the previous week, we had used persistence.xml, but in boot, we are using just the application properties. So there are many different ways in which you connect to your database, correct? So I'll just need this parameter, server time zone parameter. So, and ampersand this. So once this is done, what I will do, I need to build my project. So this is my Spring project, correct? So to build my project, I need to run a command, which is maven clean install. So if I just run maven clean install, it's going to create a target, the artifact jar files, because in our POM, we said generate the jar. So here, if you see package type, where is the package type? Da, 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 da. User relative path, group ID, dependency. I think there was a package type somewhere. Let me quickly check that. So I think we provided the package type. It's there somewhere. We'll find it out. This is what I was saying during the build the Spring initializer part. We specified that parameter. It should be there somewhere. Model version which anyway, I'm not going to spend much time on this, but I know it's there somewhere. The build is going to create that jar. All right. So once you have this, you do clean install, but you want to skip the test part because test part also has a main program, and we actually don't have uh, things annotated with uh, the things that it needs. So we'll probably skip the test part. So -d maven dot test dot skip is equals to true. Now when we execute this, it will create the, sorry, maven. It will create the target jar files here. So we run this. So it is building the snapshot. So once this is done, you will see under the target in some time, these snapshots would be ready. It might be packaging them. I'll give it some time. Yep. So your snapshot is ready. So if you just want to run this, what you can do is jar. So target is directly under the leg demo folder. So I'm under the leg demo folder. So if I do say I want to execute in Java, so Java jar type present under target, and it is leg demo snapshot jar. So if I run this, um, I should be able to run the project. So Spring is up. So starting Tomcat. So Maven is taking care of all this. So it's all running in Java. So, right. So now leg demo application is up and ready. And we should be able to test our APIs now. So I don't have a persistence.xml. All I have is application.properties. And this is the schema name. And I'm using, I don't have to specify all the mappings. I just have specified them in here. So Hibernate knows about it. Right. So if I start my application, controller, I'll open up a Postman to demonstrate. So this is my Postman. So what I do is I'll first do HTTP localhost and then 8080. That's the web port where Apache is listening to. And then I say /API and Pokemons. So it's going to call this method. Let's send a request, get a request. We'll see that some initialization happened with the dispatcher servlet and some query translatory functions. And if you go to leg demo and refresh this, you see this Pokemon table is generated now, but it is empty. That's why it didn't return me any rows, correct? So what I'll do is while this is running, um, I need to post a Pokemon object. So what I'll do is it's sending me an empty array. So I will change this to post because I need to post something. And in the body, I need to pass some text data or JSON data. I need to pass the attributes. So name and power, which are string. I'll call it name Sunil. So it has to be a proper JSON, Sunil, and power as fire, maybe lecturer. Okay. So if I post this, I don't have to post an ID because it is auto-generated. So this is the form part of the body, and I send. There you go. It's generated. Now if I add Varun and as a lecturer and send, Varun is created. Now if I change this URL to get, okay, so if I do get, in that case I'll just get return a list of all Pokemons. I have 2 Pokemons now. I'll get a array of 2 dictionaries. Now I want to change Varun as tutor, not lecturer. So what I'll do is get to put. So post is to add, put is to update, and I need to update ID 2. So /2, and I need to pass Varun, and the power is tutor, and then send. Varun is updated. Now I want to check, go to get, I can check, and I should be able to see Varun as tutor. So this is all happening using the boot service. This is microservices pattern where you create microservices and you interact with the database totally using web services. Right, so if I want to delete something, I can say a delete, and then I pass the ID or this, and it should delete. Then if I say delete, not delete, get, I should see only one, which is what is expected as an outcome. So my application is working properly. I have no issues with that. What I'll do is I'll stop the application, Control C. MySQL is stopped. Now I need to Dockerize it. To Dockerize my application, what I'll do is I'll do right click, create a Docker file. Docker file, okay. And in the Docker file, I'll have, so this is IntelliJ. This is my local MySQL. So I'll get the GitHub. My Docker file, I'll copy this part. So I need to put all my dependencies libraries here. So I need Java 8 and just create a temporary volume. I need to expose 8080 to outside. And this is a custom open source program where it says wait, wait. What it basically does is, like, if you have any other services that's been part of Docker Compose, then it will wait for a Docker Compose to finish the previous services and then run your service. And what I need to do is target, so under my target, I have leg demo snapshot. So this is leg demo snapshot. I need to copy this snapshot generated uh, to leg demo, or you can keep the same name also, doesn't matter. This is in the container. This is in your current local. All right. And then you need to make this as an executable. And then this is the entry point where you execute your Java executable jar file. Okay. So this is a Docker file. And this is how you Dockerize it. But then we're not just going to build one image. We need MySQL also to run in the container. So what we'll do is we'll have multi-services running Docker Compose. So create a file. It's docker-compose.yml. It's yet another markup language. And in Docker YML, we are going to copy the contents from here. I'm going to explain that. So we are telling to use version 3 of Docker Compose. It has two services. One is MySQL Docker container, and you have a demo, a week 10 demo. I'll probably call this as leg demo. It's creating. Just a minute. I need to stop this. I need to stop this. I just need to use a terminal. So what it says is, like, create two services. One is MySQL Docker container, and this is by pulling a MySQL latest repository from the Docker Hub, and then authenticate using MySQL native password. So this would be the root password, or you can have anything that you like. And then this is the MySQL database, and MySQL user and the user database. This is the volume point inside the container where data be mounted, and it's be in the my network. And we are going to place the image that we built under the same. So leg demo. So we're going to build this leg demo image. This is the name of the service, leg demo. And we're going to build this image. And here the image was pulled from the Docker Hub. So when we build the image leg demo, it's going to use the Docker file to build that image. And we just went through the part. So what it says is, like, it says wait for the host to be up. So you want the MySQL Docker container service to be up in 3306 port, and then you run this service in the port 8080. So inside container it is 8080. Tomcat inside inside the image container is running at 8080, and you're saying from your local host, you can reach this port through port 8087. And then for all the volumes for this specific service, let's call it select demo. And you want to keep both the service in the same network. All right. So this is Docker Compose file. So before I could use it, I would like to generate my jar file again, because I created this jar to run in my local and not in a containerized environment. So the things that I'm going to change here before regenerating my jar is application properties. So it's not going to be localhost, but it's going to be uh, MySQL Docker Container Service, and running at 3306. And the database name that I'm going to use is Spring App DB. So this DB will be created not in your local, but inside the MySQL running inside Docker container. So I'm going to put that information here. And I don't need to provide the time local information, but I need to provide SSL as false. So I'll remove this part. I'll just give, this is MySQL user. So the MySQL user for this is app user, and the password is test123. So once you have this, you need to generate. So these three files is very important looking at. So once we have all this information created, I will clean and build the jar file again. So I will do maven clean install. This time the jar will have application properties that is pointing to a MySQL running in a container. And how to build the LEC demo image is present here. And to make it up and running, we'll use this part, these two services. Right, now when it is up, we'll use Docker Compose. Before that, I'll just clear things. So we'll use a Docker Compose build. So this will build all the images. So before that, I should have shown you this. So I do have some existing image. So these two images are in use, but that's fine. What I'll do, I have MySQL from, I have existing Java 8 and MySQL already pulled, and this was created sometimes back. What I'll do is they are in use, so I'll just go and stop them. Okay, let this image is created first. So right, so your LEC demo image is now created. So you can check here, Docker image ls. So you have this image created. So if you do Docker ps minus a, sorry, my bad. Docker ps minus a. So we have MySQL up and running for last 6 minutes, and this is things. So what I'll do, I'll stop them. Okay, stop these two. So these were earlier running. I haven't run anything yet, so don't worry. Build is to just build that image, because this was running along with this week 10 demo, not with the image leg demo that we just built right now. So nothing problem. So right. So we have Java, MySQL, and leg demo. This image was created part of the previous command docker compose build. Now, if you have to run this, what you do is docker compose up, and it's going to run leg demo. So it's creating a container. So if you go through the list in detail, you will see it's starting a MySQL. So this MySQL needs to start, only then leg demo can start, because it needs to wait for the host MySQL Docker container. So if you see MySQL is starting, and it is leg demo one is keep on checking if it is available or not. So after a while, it says leg demo exited, because after 30 seconds, this host was not reachable. Docker container was not up and ready. MySQL was not up and ready. So we'll just wait for a while for MySQL to be up, because MySQL takes a bit of time to up. So MySQL is internally running at 33060 port, and it's locally listening at 3306. This is because of the GPL licenses. So now MySQL is actually up, but leg demo exited. If you want to confirm that, so you can do docker ps -a. You'll see the leg demo exited, and MySQL is running just a minute. And it's running from the host 3306 and 33060 inside the container. So what you got to do is you can gracefully stop by Control C. So you can see, so now both of them, they exited. And what we will do is we'll run the Docker compose up again. So this is just to see first. So it's starting the Docker container. So starting MySQL leg demo. So this is leg demo MySQL. So this time MySQL is up. Now leg demo is starting up, which is good. So if you see here quickly, MySQL should be up and leg demo should be starting. And leg demo also started. So still starting, it's executing the jar file. So just all right. So you need to wait for a few more seconds till you see the application is deployed. So leg demo is working. So it started the servlet engine. Initialization completed. So now when you see started leg demo application, that means now your demo application is up and ready. So leg demo is nothing but your main application here. So once this is up and ready, you should be having both of these running. So if you see, the leg demo is running at 8087 in the local, and it's pointed to 8080 Tomcat inside the container. And 3306, it is listening in the local, and it's pointing to 33060 in the container. So if I pull up my Postman here, and I say localhost 8080, there should be nothing running because there's nothing running in 8080 local, right? Error refused, but it is running something in 87 in the local mapped to 80 inside the container. So it should return me an empty thing because it's a get request, and because the database is just initialized, there is nothing inside the database. So right, so we got a 200 response with empty result set. Now what I will do is I will post some data to Pokemons. I'll call it Varun as lecturer, and then I send post data. It should create an entry in the database container. Wow, that's good. And if I add one more saying Sunil, the post request, it added Sunil. Now if I want to update something, which we did previously, and I want to update one with Varun as tutor. In that case, it will update in the database running inside the container, correct? And then if I do a get and do this, I should see all the content of the Pokemon table inside the container. Now, if you want to go inside the container and see where this data is stored, what you can do is you can use this. So we'll do a little bit of deep diving into the container. So I'm here, and I will say, so that's Docker PS, that's my container ID for the MySQL. And I'll say Docker execute 80 in the container and open me a bash terminal. Now we are inside the container, and if you do ls, you see data MySQL, or that's data cd/data. So this is where your volumes local volume is, but that's not my point. I'm here to go into MySQL, so I'll say MySQL. User is root and -p, and then it'll ask me for the root password. So root password is root pass, which I have passed as an environment variable. So root pass. So now I'm inside the Docker MySQL. Okay. So I have a schema, and the name of the schema is Spring App DB. So I'll say use Spring App DB. So database is changed, and now I'll say select star from Pokemons. So sorry, it was Pokemon. Now I have the details, same details what I have in my Postman. Right. So what we have done here is first what I'll do meanwhile I'm here is I'll first exit this and then exit from the container, and I will close this process. I'll do Control C and it will stop. It will stop both. So if I do Docker PS now, it should be exiting both. Okay, started, take some time. Okay, now it's good. So now I can do Docker stop this to stuff and Docker remove this, Docker stop this and Docker rm this. Cool. Now this is cleared up. What we did first was we created a local project, local Spring Boot project, and we created controllers, entities, Pokemon, something very similar to Spring Framework, which we learned before. And in the database connectivity, application properties is basically a file to locate parameters to connect to external resources. Here, external resources is a database. So we used a local host MySQL, and we had a different DB there. And then we use the root username and the password to log into that. And Hibernate properties we specified here. And we generated the jar file executable through the maven clean install command. So once we generated this, we executed that to check it in our local host in the port 8080. And once we are happy, we changed this to MySQL container, because that's the name of the service in which MySQL is running in the Docker Compose. And there's the name of the Docker MySQL database name. This is the MySQL user, MySQL password. This is MySQL user, not the MySQL root user. And then we have two files created. The first one was Docker file to create an image out of this executable. This will create the image out of the executable artifact that was generated, the jar file. And then we have Docker Compose, which creates multi-service container. So so it created one service, MySQL Docker container. And then we have created another service, leg demo, created from the image leg demo. And this leg demo was actually built, not pulled from the Docker Hub, unlike in the MySQL, which was pulled from the Docker Hub. This was built from the Docker file. And then you have some weight parameters where this service won't be up until this service is up. And then you are mapping the port, just like when we run the Docker, we say -p host port to the container port. We change that, and we specified both of them to have in the same network. And then we build the Docker Compose. Docker Compose build created the image leg demo and pulled whatever required. So if it is nothing there to build in Docker build, it's not going to build, but we have one service, one image to build. in the Docker Compose. So when you do Docker Compose build, it will build this image, and you'll have this image created. So once you have that image created, when you do Docker Compose up, it's going to make the services up and running for you. And once that is up and running for you, you just monitor that both the containers are running. And once you verify both are running, you can run your commands to test your APIs. Yeah, that's all. Thank you very much.